Okay. Okay. So, are we live? All right. Okay. So the state of the art. Um, so we're thinking here about, I was finishing the summary and I wanted to say, provide a little synopsis for people on what we're thinking so that they can quickly see, what we're up to. So I thought, maybe we should use this tag state of the art. And that way, we can basically search through, or Alice can search through at a later date to understand within a given train of thought, and within the things that we were addressing, right, within that given train of thought, which basically mapping, and this unfortunately that there's so much intermixed here, so we're gonna have to decipher the trains of thought, which is obviously where we get into like, I think there's something about those phylogeny whatevers where we can start looking at them to understand how thoughts differ from each other, right? So one possibility, right? But those are with shared ancestors, so I think I'm not sure quite how that ends up working out. So I think this might be different than that. I think there just might be some concepts that we might want to borrow. So, anyways, so this state of the art. So basically, the state of the art. At the end of the day, what we decided is we're gonna spin up this example DID-based blockchain using Firefly. We're going to dump it to cold storage, which is a file. We're going to inspect all the records in the chain, and then we're going to understand how each record maps to what is seen or unseen in the Firefly Explorer UI, right? So basically, where was the Firefly stuff, right? So tutorials, uh, work with custom smart contracts, Firefly interface format. Okay, see, this looks great. We should grab this too later down the line. Okay, so we can also say, okay. So basically, and then I was looking around and then I basically found this thing which says, um, this Firefly thing, which says, this is how you have create a blockchain event listener. So we might, use this event listener endpoint from Firefly to basically then, um, you know, run this within KCP, within DFFML, within KCP to then act as a proxy to the KCP API, and a KCP or in Kubernetes as the API server there is the Web 2 interface, and then this, then we're communicating also. We're basically bridging the KCP, we're bridging the Kubernetes API server to the DID based blockchain, so that we can, issue our jobs on top of KCP, which will use for the orchestration, right? So we're going to use KCP, we're going to use Kubernetes API server for the orchestration, and we're going to have the communication layer be this DID based blockchain, right? And so that way, basically by loading the DIDs into the blockchain, we execute the series of Kubernetes jobs required. Um, uh, Basically by, this little listener will sit here and it will, it will do our permutations thing. So the listener will sit there. Let me write this down. Okay, so listener. So listener within KCP that listener within slash alongside KCP acts as Web2 to Web3 proxy, where Web2 is the Kubernetes API server. So this proxy service initiates, looks at incoming GIDs and proxy service. So question mark. Supernode, just run supernode. So basically, there's this concept of the supernode, right? So for our basic implementation, we might say, hey, let's just run the supernode, and then we could plug in, whatever framework that we want. So basically, this proxy service just runs supernode to start, write operation to start supernode on KCP cluster start. Okay. So write operation to deploy supernode on KCP cluster start. So listen within / alongside KCP acts as Web2, Web3 proxy, where Web2 is the Kubernetes API server. This proxy server, which maybe we run the supernode to start, but basically we're going to write an operation to deploy supernode to KCP cluster. So this operation looks at incoming. So either listens and itself looks at incoming DIDs and does something with them. So this is alternate transport mechanisms. So this could be data flow, which triggers Kate's API triggered via non DID proxy. Alternate transport mechanisms. Alternate transport mechanisms could be data flow, which triggers Kate's API triggered. So this proxy service will kick off DFFML to either kick off operation to deploy supernode, Firefly supernode on KCP cluster, on KCP cluster start. So it's either the Firefly supernode or the blockchain node. Not sure. I think it's the Firefly supernode. So this proxy service will either kick off DFFML, to either kick off. So this proxy service on start will kick off DFFML to either kick off operation to deploy Firefly supernode on KCP cluster. Start listening itself for DIDs incoming as and converts them into K8's specs to call job subclass CRDs, which we define via templates created from operation slash uh, operation type information given via input via definitions input output definitions and config as data class with unified with soon to be unified Python typing and definition system or approach. Okay, this proxy service will start the kickoff operation, employ Firefly supernode or blockchain node on KCP cluster, start listening itself. Maybe on KCP cluster, configurable with data flow. Okay, or maybe it starts listening itself, or some hybrid thereof. Okay. So basically, yeah, we've then found in the process of me trying to show you the UI, but basically we're just going to start a blockchain. We're going to dump it to cold, and hopefully they have some example ones where we just jump in and use some of the example data they already have. And then we will dump it to a file. We'll look at all the records. We'll see if they match this JSON structure we're seeing on the right here. And if they do, then, or if they don't, we're going to try to figure out if somehow they do map and we're just not seeing it, or if they are truly different, then we'll basically say we'll either do more research and see if we're just missing something, or we'll just go skip this blockchain stuff for now. And then we'll, and so we'll look at that data, we'll see if it maps. If it does map to this format, then we're going to do, and this is just the typical stuff where you do when you're reverse engineering or fuzzing, right? You're going to look at the data format, and then you're going to sort of, map to how do I reconstruct that data format with my potentially malicious inputs if you're fuzzing. In our case, we want our, correct inputs, right? Because we're re-implementing essentially based on that we're implementing interoperability by communicating through this format, right? And we're going to see if we can then reload the format using what we tried to do we're basically just going to make some stub operations which return the static values, which are the same values we found from the dumped contents of the blockchain. And obviously we're going to accept that the IDs are going to differ and maybe the keys are going to differ, but as long as when we import it into Firefly, it can see all of the nodes and all the relations, and we can then, maybe still add some things and use the data, right? Then we're going to assume that, okay, we can have interoperability as long as we serialize to this format, and we have already serialized to this format. So then the next thing we'd need to worry about is import from that format, right? But we don't have to tackle that yet. We would tackle that after we do the data flows class stuff. And then we looked and we saw that there's this thing about custom contracts, and that they have this event listener. And so we were thinking down the line as we go to do this deployment where we want to use our orchestration via Kubernetes, via the Kubernetes API server, and therefore KCP. We're thinking that maybe when we launch our Kubernetes cluster, whatever the orchestrator is that does that, it will go ahead and configurable probably with the data flow for on startup of the orchestrator to start KCP or Kubernetes or whatever. It will maybe either deploy the Firefly supernode and then make that the interaction point that it maybe even bridges one Kubernetes cluster where you're actually deploying the supernode, which is outside of your network, and it maybe even like using the KCP interface to bridge multi-cluster, potentially even makes that maybe that thing that's in your edge deployment situation, maybe you're running KCP on your IoT device, right? And then you say, hey, I'm going to need a connection to a supernode, right? And so then you communicate um, over via, you're communicating via your DID based protocol over something like, just like the local Wi-Fi, right? And you say, hey, you send this DID out over the local Wi-Fi, maybe as on a TCP connection that you identify, from you can do like a UDP multicast, and then you can do this discover response on the local network. And then once you have the discover response on the local network, you can establish that, hey, I need to make connection to this. Um, Machine locally, and it's kind of like this discovery protocol. And once you have the discovery protocol going, you can say, okay, like, hey, we talk DID on this discovery protocol. And so then you send a DID over to it, and it might be running a Kubernetes cluster on it internally, and it could spin up, it could say, hey, I want to deploy Supernode, but I'm resource constrained. So I need somebody, I'm communicating out to this network of devices that's nearby me, and I'm saying I need Supernode. Does anybody have a running Supernode that they can communicate over this channel, which might be this underlying channel, which is like this, TCP that we discovered on the local, the local, maybe the local LAN, right, where we did some UDP, the multicast, or the broadcast, the UDP broadcast. Um, is it multicast or broadcast? I can't remember. Um, to find this local service that talks DID. So basically, as soon as you find something that talks DID, then you act as a bridge, right? And then you sort of work together, right? The devices work together because they send out the pieces of the strategic plans that they want the other devices to help them with, right? And so if you're an IoT device and you're like, hello, hello, I just came online, I need a Wi-Fi network, right? I think there's some stuff going on about, this sort of like IoT devices hopping Wi-Fi networks, right? But we'll want to look at that and leverage that as well, right? Um, but yeah, so for now though, basically, you can imagine that basically these DIDs get issued, and then all of these little proxies along the way basically look at the DID and they decide, okay, based on the properties of it and what it's requesting, you're applying your appropriate sandboxing before you actually issue the request, right, to the Kubernetes API server to launch that job, right? And that is sitting within this little whatever this container is that's running, or whatever. Maybe it's not a container, maybe it's just a little WebAssembly process, or maybe it's just a little C process or Rust process on this little IoT device that's just sitting there, and it's like awaiting DIDs and then doing method calls, right? And it's doing, so it's RPC, but it's RPC, so it's RPC on everything asynchronously, with sort of the assumption that you're going to be having some ML models run in there. Um, and you're doing these configurable asynchronous event loop based RPCs. So it really is like you're running all this little you're running all this little WebAssembly at the end of the day, where it's like this little event loop environment, like it's a browser where you're having almost these service workers on all of these devices, right? And the service workers, some of the things that they're doing are, maybe with some of their built-in config, calling out to some native APIs that might be doing machine learning using those networks that we trained in the strategic plans to make decisions on the fly, right? When they're not going to be able to priority-wise communicate back with their main network to get new strategic plans. But all of that you would be calculated when you're sending this stuff out and then communicating back. And so, okay, and so, okay, so yeah, so that's kind of just, and so in that proxy, basically you can sit your, this is where you can sit your input validation, and this is where you can sit a trust boundary really nicely, right? So, and you can have those different inputs as they get decoded out of these different DIDs or sources before they go into the Kubernetes API server. You're validating them, and then you're maybe validating and splitting off and running and instantiating new Kubernetes API servers, which are going down and building and calling into these synthesized CRDs, which are then calling into the underlying operations, which are actually the little Python functions, right? Or whatever functions in whatever language, right? And so you can then leverage your data flows and your overlays and all of that to make sure that um, um, uh, you can leverage your data flows and overlays and all that to be sure that before anything calls any API, because you're allowing arbitrary people to do remote code execution, just like kind of a browser, you've sandboxed the permissions within your user's degree of comfortability, right? So this is like all these websites out there are running all this JavaScript and they're trying to track you and stuff, right? Um, and so if we provide them with this environment, which is not like run all your arbitrary code and then you can do these weird, like timing side channels and all this shit, like forget that. We're going to give you a set of defined interfaces, sort of like the browser API, right? And we can come to agreements as ad hoc groups of devices and individuals working to different sort of areas what these interfaces are, right? And uh, and so basically then we overlay those and we apply those as like, the cross between the trust boundary and the input validation, and then you can also bake in your system of reward, I believe, using some of these DID things and the smart contracts aspect of that. But then you basically, yeah, you add in all the provenance information also. So this has been another video, and I've said the same thing a different way a few more times. So uh, you know, give some feedback, if you will, if you feel that I'm sure things are not clear. Please let me know what is not clear. I think appreciate Sahil coming on today and talking. That was fun. It was good to hear some more feedback. Talk to a few people. I think we're getting more feedback on this, but we got to come together and collaborate on that, on throwing some ideas at the wall here and see, how do these things map out really, right? Because we know what we can see, and we see like this release a few days ago from these Firefly people, but it's always changing. So um, let's figure it out. Cool. All right. Thanks again. Bye.